Hi everybody, today we're going to talk about division, equal shares and equal groups. Objective, I can solve division problems by using counters, pictures, diagrams, or arrays. Let's look at an example of a division story problem. Lindsay and Matthew share 14 pennies equally. How many pennies does each child get? I'm first going to draw an L for Lindsay and an M for Matthew. Next, I'm going to divide up the pennies between each person. One for Matthew, one for Lindsay. One for Matthew, one for Lindsay. I'm going to keep dividing or splitting up the pennies until I've used all of them. And then, once we've used them all, we'll be able to see how many pennies each person has. All right, all the pennies are used up. Let's count them. 1, 2, 3, 4, 5, 6, 7 for Lindsay. And 1, 2, 3, 4, 5, 6, 7 for Matthew. So each person gets 7 pennies. Now, because we have split them up, we have used division. So I need to write a number model that uses division. I'm going to start by writing 14. That's our biggest number. Our biggest number always comes first when we do division. We started with 14 and then we divided. Division sign is a line with two dots, one on top and one on the bottom. We divided these pennies by two people, Lindsay and Matthew. So we're going to write a number 2 here, and that equaled an answer of 7. 14 divided by 2 equals 7. Here's our next story problem. There are 18 cents. A group of people are sharing them. How many people could get 4 cents? This problem's a little bit different because we don't know how many people there are. We do know we have 18 cents and each person that's there is going to get 4 cents. So what we can do is take these pennies and put them into little groups of 4. I know this person will get 4 cents, so I'm going to put one group of 4 here. Another person will get 4 cents because each person is getting the same amount of pennies. So we're going to put one little group aside for that person. We're going to set one group over here for the next person. And one group over here for this person. Now notice what happened. We have 2 pennies that are here, but I need 4 to make a group. I'm going to leave these 2 pennies sit here for just a moment. When I think about that question, it said how many people could get 4 cents. So I'm going to look at how many people got 4 cents. There's 1, 2, 3, and 4. If I'm answering this question, the answer would be 4, and the unit is people. 4 people got 4 cents each. Now, let's go back to these 2 pennies down here. If I were writing a number model, I would want to write what I started with, 18 divided by the 4 cents that each person got would equal my answer of 4. But then I also need to include these 2 pennies over here if I'm doing a division number model. When we have 2 left over, a leftover amount in division is called a remainder. We write R for remainder, and then we write how many were left. There were 2 left. So if this problem had asked for a number model, it would be 18 divided by 4 equals 4 with a remainder of 2. However, the question I had today just said how many people could get 4 cents. In this case, my answer is just simply 4 people. Here's another problem for us to solve. There's 12 pennies and 3 children. How many pennies does each child get? I'm going to first draw my children off to the side. Here's child 1 with the smiley face because they're happy that money is coming his or her way. Here is child 2, and here is child 3. Now what I need to do is take my 12 pennies over here and divide them up. So I'm going to give 1 to this person, 1 to this person, and 1 to this person. I'm going to continue dividing up the pennies until I've used all of them. All right, we are all out of pennies. Now when I look back at each person, I can see that each person gets 4 pennies. So the answer to the question is 4, and the unit is pennies. If I were asked to write a number model, I would write what I started with, biggest number first in division, 12, and then I would write divided by the 3 people that were there, which equaled my answer of 4. 12 divided by 3 equals 4. Another problem, this time there's 12 pennies and there's going to be 2 cents for each person. The question says, how many people get 2 cents? This is another kind of problem where we don't know how many people there are, but we do know every person that's there is going to get 2 cents. So we can set aside groups of 2. 2 cents for this person, 2 cents for this person, 2 cents for this person, and we're going to continue going, dividing up the pennies until we've used all of them, putting them into little groups of 2. Now we're finished. We need to just count our groups. We have 1, 2, 3, 4, 5, and 6. So there must be 6 people. How many people get 2 cents? 6, and the unit is people. Our division number model would look like this: 12 that we started with divided by the groups that had 2 cents each, which gave us our answer of 6 people. Here's another story problem. 12 children want to play basketball. How many teams can they make with 5 players on each team? Can all the children be on a team if each team has exactly 5 players? Can all the children be on a team if there are 6 children on each team? We have 3 questions to answer. Here's question 1, here's question 2, and here's question 3. We need to make sure we answer all of them. Let's start with what we know. We know there's 12 children that want to play. So I'm going to draw circles to represent each of the children. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now I'm going to look at question 1. How many teams can they make with 5 players on each team? So I want a team of 5. I'm going to go ahead and circle 5 of these children. 1, 2, 3, 4, and 5. There's my first team. 1, 2, 3, 4, and 5. Here's my second team. Notice I have 2 left. I can't make a team of 2. It wants teams of 5. So question 1, how many teams can they make with 5 players on a team? The answer would be 2 teams. Now we're going to look at question 2. Can all the children be on a team if each team has exactly 5 players? The answer here is no, because we had 2 children over here that did not make it onto a team. Now we're going to look at question 3. Can all the children be on a team if there are 6 children on a team? So instead of 5 children on a team, they want to know can all the children be on a team if we put 6 onto a team? So we're going to take this child and add them to this team. Now that team has 6, 5 that we started with plus 1 more. And this child can be a part of this team. And now that team also has 6 players. So the answer to question 3 is yes. All the children can be on a team if we put 6 players on a team. it's time for you to do your homework problems. Here is quiz question number 1. Please write it in your math notebook. There are 16 pennies on the table. 4 children want to share them. How many pennies does each child get? You don't have to copy the whole story problem, but please show your work, write your answer, and label it with a unit. Quiz question number 2. There are 15 pennies on the table. Each person gets 3 cents. How many people get 3 cents? All right, this is another one where you don't know the number of people. That's your job to figure it out. How many people would be able to get 3 cents? Again, show your work and write your answer and label it with a unit. And quiz question number 3. Alex is holding soccer tryouts. There are 14 children wanting to be on a team. 6 children can be on each team. How many teams can Alex make? A picture would be a great way to show your work for this problem. And then remember, you want to answer the question, how many teams can Alex make? Please write your answer and label it with a unit. And that is all for today. I will see you in class soon.